go back into Game1. It occurred to me that we don't have our font set up yet, so let's add a sprite font, call it font. Also, now that we've created a map, we can add a map, and since we've created an editor, we can have an editor. Let's go into initialize, and we'll initialize our map using our sheet list, or sheet part list, I should say, and SpriteBatch. We'll go down to load content, and we'll load our font. Font is equal to load. We're loading a sprite font. We'll call it font. Now go into content, the mono game pipeline, and let's add a sprite font. New item, sprite font description. We're going to call this font. Let's open it, and here we can customize certain things. So let's change the size to 14, make it a little bigger. Change the style to bold. That should be good enough. Let's save it, exit that. Also, in load content, we'll also have the initialization of our editor, which takes in the map, input handler, and our sheet list. And later we'll probably add player and monster management. And now that our tiles image, or the sheet that contains all our tiles, has been loaded, we can set the texture map, or sprite sheet, that will be used for the tiles as tiles images in the map. Tiles image, actually. Let's change tiles images to tiles image. Okay, now we can use our sheet manager to set up level 1 coordinates for that image that holds our tiles. I'll just skip adding the comment here. And we'll put a border around the map so that we don't fall off the map when we're testing it. Number 6, if you look in sheet, go to sheet manager, number 6 was a single 1x1 solid tile, so we'll use that. Also, let's have the editor load the default level because we may be in play mode. If no level is created yet, it'll just return because the file doesn't exist, as you can see here. Go into your update, and we'll update the map, which currently doesn't do anything, so there's nothing to update in it at the moment. We'll also want a way to switch back and forth between play mode and edit mode. So let's go add some game states up here. Just comment here. Game states. We'll enumerate the different game states as edit, play, game over, menu, and load level. And the default game state, games, is equal to GameState.play. And then we'll have it so that you can hit E to go to edit mode. Let's go back down to update, and we'll set up a switch based on the game state. So in the case that the game state is play mode, and you're playing the game, let's check if the game state changes. Key press, keys.E, we'll set the game state to be GameState.edit. And while we're in play mode, let's have it so that it updates our bounce manager that we just created. And although we created it, we didn't actually set one up in map, so let's go to map. Right after start data, let's add the bounce manager. Call it bounce, mgr, go down to the construct, and let's add the creation of the bounce manager, which takes a reference of the tiles. But we'll actually call the update in Game1 like this. So let's add another game state. Edit. In edit mode, we'll need to set up the camera position to be equal to where the camera is located on the map. Convert it to vector, the location, and times 64, because they're 64 pixels wide, 64 high. So it'll multiply 64 by both components of the vector. We'll update the editor, getting the various inputs for editing the map. And if we want to switch to play mode, let's use the key press, enter. Easy enough to remember. If the character dies, the game state's game over. If input key press keys.escape or key press keys.enter, then we'll exit. Just add an extra bracket there. Let's go down draw it, and we'll draw our map out. So make a little section here for that. And we'll set the device states, alpha blend, and make sure that you have your graphics set up for pre-multiplied if you're using alpha blend. If it's non-pre-multiplied, then you would want to use pre-multiply as false. Sampler state, linear clamp, stencil state, I'll say none. I found on one of my graphics cards I was getting better performance with depth turned off. I'm drawing 2D, so we don't have to call anything. That's just for triangles that are facing away from the camera. We won't have any triangles facing away from the camera. Alright, call map.drawTiles, and that should draw our tiles whether we're in edit mode or play mode. Let's just mark this clearly. Okay, so here we're going to draw crystals, and anything with effects or different kind of blending that we want to put over top. And then we want certain things to go over top of that, which will be our overlaps. So we'll end up switching back to not using an effect. So we'll have to call a new begin end again. And you don't want to do this too often, but sometimes you have to, because you don't really want to change device states very often. Or textures. We call map.draw overlaps, and that should do the trick. And here, we draw other additive effects that go over top of those too. We don't have any yet, so we'll just put this comment in here so we know where to put it. And if we're in the game state, let's edit, then we can draw our locators, which show where certain things are in the map, collision, stuff, or monsters. Pass in the variables it needs. This should be tile images, tiles image. So if our game state is play mode, let's tell, and this is only for development, we'll have this instruction in here just as a reminder, using our font, saying press E, go map editor. At 1 over and the bottom of the screen -50, so near the bottom, and do it in dark green. Oops, I made 2 brackets here instead of 1. Okay, we'll copy that line. And I'm just using a technique here to make it so it's easier to read it, like if you had a green background. So this one would be at 49, and we'll say green, yellow. These two will contrast each other, make it a little bit 3D, make it easier to read. So let's put it on a single line so we don't have to look at as much code. Otherwise, we're likely in the editor mode, so let's draw our editor instructions. Draw instructions. Pass in reference to the SpriteBatch and the far background, the font for drawing in instructions, and the screen height dimension. Okay, it just occurred to me that I should take this out of here and bring it down to here. Let's go back up to the top of our draw and consider a scenario where we don't want to draw any of the tiles or anything, like if it's a game over screen. So the only times we'd be drawing all this stuff is if the game state was in edit mode or play mode. So let's make a cheap and an easy way to skip drawing this stuff without making a whole bunch of nested curly brackets. If the state is not edit mode, play mode, we'll go to a label called draw other states. Some people might freak out about the use of go to, but this is one of those scenarios where it makes sense to use it. So let's go down and put in our label. And I do agree that you want to minimize use of go to as much as possible, and if possible not even use it. But this is one of those times where this makes the most sense. So here's our label, draw other states, and anything between that point and this point is stuff that's only going to happen during editing or play mode, just something to keep in mind. And the only other state right now we want to handle is the game over state. Clear the graphics device, color black, clears the screen, and we'll draw a string using our font saying game over. At the screen center plus, go backward 80, up 20, lime green. Let's do press enter, sort of centered in the same way. And instead of going up 20, we're going to go down 20, so positive 20. And I would say SpriteBatch end. We'd like to add the player class next, but before we can do that, because our player class and our monster class are going to use MeoMotion features, we want distortable vertices for rendering quads of any shape we like. They don't have to be squares or rectangles, and that way we can animate in a way that looks more bouncy. So first go to Platformer, right click on it, we'll add a new class called QuadBatch. Type in QuadBatch. It'll be just like SpriteBatch essentially, with some differences, which I'll explain. And I'm just going to add a comment up here. Okay, so our QuadBatch will need some device states, starting with blend state, sampler state, depth stencil state. Let's resolve these first. The default for depth is typically off, but you can use it if you want to use occlusion or something like that, or if you actually want to use depth for your layering process. But since we're using alpha transparency and we have a lot of irregular shaped sprites, we'll want to layer in order pretty much regardless of what mode we're in. We'll need a default shader, That'll hold your default vertex shader and pixel shader. If you override either the pixel shader or the vertex shader, you can do that with another effect. If that effect isn't null, and say it just has a pixel shader in it, then it'll just override the pixel shader from the default shader, and it'll continue to use the original vertex shader that was set. You could also change both if you wanted. We'll make the origin default publicly available. Normally it would be 0.5. Actually, I don't know why I'm making it publicly available. It doesn't need to be. So depth is the default depth that the vertices will be set to. Those could be adjusted on the fly if you needed to. We'll take as parameters a screen width and screen height once, but you could also change them externally when you needed to. So we'll make those publicly available, like if your resolution changed. Graphics device, that's your graphics processing unit or GPU. Sometimes I'll actually call this GPU. We'll call it device, just because that's what most people are calling it. We'll use the vertex position color texture as the format for our vertices. And if you've studied DirectX at all, you'd know that there's a bunch of different vertex formats and declarations that you can use. For our purposes, this would be the most common one we'd use. So we'll also want to use texture fonts. So let's also set the texture's horizontal and vertical spacing parameters, which can be modified externally. And we might want font depth to always be at a different depth, so we'll use a different variable for font depth instead of just depth. We'll also need to set up the indices, which will be short int16 indices, so 16-bit integer. And we'll also need our vertex and input and index buffers. So the vertex buffer, this is what holds all the vertices and sort of passes them along into the graphics card. We'll need to know whether or not begin was called already to avoid possible errors. Also, was a font texture loaded? By default, false. We'll have a vertex count and a font vertex count. Keep track of how many we currently have added into these lists here before we push them into the vertex buffer and then have that fed over to the GPU. Default font size is going to be private, but it can be changed using a set. And we'll need some matrices that the shader will want for putting the vertices in the right places. World matrix, view matrix, projection matrix. The font will need the same sort of thing. View proj is just combining the view matrix with the projection matrix. And world view proj is the world view and projection matrices combined into one transformation matrix. Use the same sort of thing for the fonts. So we'll start with the constructor for QuadBatch. To load our effect, we'll need access to the content manager. Resolve. We'll also need our graphics device, the name of our default effect file, the name of the texture font file, and optionally screen width, and optionally the screen height. We'll have a vertex declaration, which determines what type of vertex format we're going to be using. I'm not so sure we need this anymore like we used to, because we actually pass it in when we're setting up the vertex buffer. And default shader, so we'll load an effect, and it'll be the default effect file. And I'll show you how to set that up soon. We'll set our graphics device, or GPU, or the interface to the device. We'll set screen width if this value that was passed in has value, because it's optional. So we'll say screen width is equal to screen width.value, since it has value. Otherwise, since it doesn't have value, we're just going to set it to be the device's viewport width. Copy that line. This will be height. By default, begin called should be false. Should be anyway, but we'll just set it. Vertices, we'll set up some memory for the vertices in our desired format. There'll be 8,192 of them, which will give us 2,048 sprites per render. We can do the same thing for the fonts, the font verts. Well, yeah, I guess we can set our vertex declaration. .vertex declaration. Like I said, I don't even know for sure if we need that anymore, but we'll just set it just in case. So we'll get some memory, 2048 sprites times 6 indices Each sprite will consist of 2 polygons, so each polygon is made of 3 different vertices, and we have to indicate which of those vertices it's going to use. That makes a total of 6 indicated vertices, or 6 indices, for each sprite. The reason why we use an index buffer and indices is because the number of vertices that are actually going to be processed is reduced, because the same vertices are shared for some of the polygons. That way you don't process the vertices twice. So the first index points to I plus 0, which obviously in the first loop is just going to be 0, and that's which vertex that index will represent or will point to. Then we increment C, and we tell it what the next one it should point to should be, increment C, and continue this pattern. The next polygon starts by pointing at 2 and 3, and then to 0. Let's add another pair of polygons in here. We're basically doing 2 sprites every loop. The loop's unrolled, it's not really necessary. So we'll create our vertex buffer, and it'll be a dynamic vertex buffer, which needs the graphics device. And we'll give it our vertex declaration, position, color, texture as the type, 8,192 vertices, and the buffer usage we want is write only. As for the index buffer, which we'll create now, it's not going to change. It's the graphics device, and its type is going to be short. 16-bit integer is 1,288 indices. Buffer usage is also write only. And as I said, the index buffer is always going to point to the same vertices. Doesn't need to change. So we'll set the data now as the indices that we just created. We'll also set up the original default, which is where our sprites are going to rotate. And by default, they rotate in the center. Set up the 2D camera. And we'll create that down here. Set the world matrix as identity, which basically means there's no world translation or rotation or anything by default. Our projection matrix, this is the one that determines how graphics are translated from the 3D world onto the 2D screen. We're going to create an orthographic off-center. Off-center because we want the corner to be at 0, 0, and we want it to act like screen coordinates. Without saying off-center, the center of the screen would be your 0, 0, 0, and we want the top left point of the screen to be 0. So first parameter is left, which is 0, right, which is screen width, bottom, which is screen height, and top, which is also 0. The near plane will set to -2000, and the far plane will set to +2000. So after transformations in the Z buffer, the pixels that are generated will be normalized to be between 0 and 1. And because the pixels don't really center where the pixels should light up, we'll have to offset them by a tiny little bit to get them to line up correctly. So we'll create a translation to move the pixels correctly by -0.5f, so half a pixel, and then we'll factor that into the projection matrix. So the projection matrix now has that translation added into it. The viewing matrix will just be an identity matrix, meaning that it won't make any changes. Default depth will set to 0.0. If you check the website, there's more detailed information about how these matrices work and why they're used. A lot of this is going to be familiar to you if you've worked with 3D programming. Graphics cards are designed to accelerate graphics specifically for polygons or 3D-based graphics processing. So we're basically making it do 2D graphics using 3D graphics. The advantage of that is you could potentially integrate the two quite easily. So what we've done right here is we've combined the viewing matrix and projection matrix into a single matrix, and then combined the world matrix with the viewing projection matrix. And then we've copied that to the font worldview projection matrix as a default for it. The world matrix right now and the viewing matrix right now don't really do anything. It's more the projection matrix that we're interested in. But if we wanted, we could adjust the world matrix later for certain types of effects like earthquakes or something like that. Okay, let's set our default device states. Blend state dot alpha blend, sampler state dot linear clamp, and the depth stencil state to depth stencil state none. If the device rasterizer state call mode is not equal to call mode none, then we'll set it to call mode none. We want to be able to set our own pixel shaders, so we can do that with the setEffect function, which sets effects to effect. And if we want to set the world projection matrix, we can do that too. And then we should update the world view projection matrix, which is actually passed into the shader, so that's important. Same idea for font version. Combine the three matrices.